Let's find the exact value of the sum of a cosine using inverse functions. This means that we're going to need to use the inverse functions to be able to find the missing measurements and then use the cosine formula to pull it all together. For the first part, the inverse sine of negative 12 over 37 is going to be some angle, let's call it alpha. That means that the sine of alpha equals negative 12 over 37. For the second one, the inverse tangent of 5 over 12 equals, let's call it beta. That means that the tangent of beta is equal to 5 over 12. Tangent is positive in the first and third quadrants, and sine is negative in the third and fourth quadrants. However, sine and tangent inverses are restricted to the negative pi over 2 domain. And so that means that it can only be either in the fourth or the first quadrants. And so that means that sine has to be in the fourth quadrant and tangent has to be in the first quadrant. The sine of alpha is negative 12 over 37. That's opposite and hypotenuse. The tangent of beta is 5 over 12. That's opposite over adjacent. You can use the Pythagorean theorem to find the missing values. 37 squared is equal to negative 12 squared plus the x value squared. The x is then equal to the square root of 37 squared minus negative 12 squared, which is 1,369 minus 144, or the square root of 1225, which is 35, and x is positive in the fourth quadrant. R squared is going to be equal to 5 squared plus 12 squared, or r is equal to the square root of 169, which is 13. Again, that is a Pythagorean triple. So is 12, 35, 37. Now we have our values. So we can use the cosine formula. Let's say we are talking about the cosine of, remember that this inverse sine was alpha and the tangent was beta. So we're looking at the cosine of alpha plus beta. And cosine formula says we are going to be doing cosine cosine minus sine sine. Filling in the values we have, the cosine of alpha is going to be adjacent over hypotenuse, or 35 over 37, times the cosine of beta, which is going to be adjacent over hypotenuse, or 12 over 13, minus the sine of alpha is opposite over hypotenuse, or negative 12 over 37, times the sine of beta, or opposite over hypotenuse, which is 5 over 13. Those two minus signs actually become an addition sign. 35 times 12 is 420. 12 times 5 is 60. 37 times 13 is 481. And so that becomes 480 over 481. Let's find the exact value of tangent. So we can use the tangent sum of difference formula. The tangent of u plus or minus v is equal to the tangent of u plus or minus v over 1 minus plus tangent u tangent v. And remember, if we're talking about degrees, we are using 30, 45, 60, or 90 in some combination that's going to get us a value on the unit circle. When I'm looking at possible values, it shouldn't matter which combination you use as long as you get to 165 correctly. Now, I could take away 30 and see if I could use some combination of 30. 165 minus 30 is 135, which is on the unit circle. So I could do the tangent of 30 plus 135 degrees. Or let's say I could take away 45. That's 120 degrees. So I could do the tangent of 45 degrees plus 120 degrees. Both of those values are also on the unit circle. And it shouldn't matter which ones you use, you're going to get the same value. The tangent of 30 degrees plus 135 degrees is the tangent of 30 degrees plus the tangent of 135 degrees divided by 1 minus the tangent of 30 degrees times the tangent of 135 degrees. Now, you can go ahead and find tangent by taking the y value over the x value, or you can already have written them out. I've written these in a table when I was writing the tangent functions for section 5.5, so you can refer back to those values. The tangent of 30 degrees is root 3 over 3. The tangent of 135 degrees is negative 1. 1 minus the tangent of 30 degrees is root 3 over 3. The tangent of 135 degrees is negative 1. So that's going to be root 3 minus 3 over 3 divided by 1 plus root 3 over 3, which is the same thing as root 3 minus 3 over 3, divided by 3 plus root 3 over 3. I'm going to multiply by the reciprocal. I will get root 3 minus 3 over 3 times 3 over 3 plus root 3. So I have root 3 minus 3 over root 3 plus 3. And I am going to rationalize my denominator by multiplying by the conjugate. And the numerator, root 3 times root 3 is 3, minus 3 root 3, minus 3 root 3, plus 9. Root 3 times root 3 is 3, minus 3 root 3, plus 3 root 3, minus 9. That simplifies to 3 minus 6 root 3 plus 9 over 3 minus 9, or 12 minus 6 root 3 over negative 6. And I'm going to divide out that negative 6 to give me root 3 minus 2, because 12 divided by negative 6 is negative 2, and negative 6 root 3 divided by negative 6 is root 3. If you had not rationalized your denominators, or if you had used sine and cosine rather than the actual tangent value, it might have that you did not have to rationalize your denominator. It might have been a little bit easier. Okay, next we are going to verify this identity of the cosine of 3 pi over 2 minus theta equals negative sine of theta using the cosine formula. Remember that the cosine of u minus v is equal to the cosine of u cosine of v plus the sine of u sine of v. Okay? In this case, u is equal to 3 pi over 2 and v is equal to theta. The cosine of 3 pi over 2 minus theta is equal to the cosine of 3 pi over 2 times cosine of theta plus sine of 3 pi over 2 times sine of theta. Think about the unit circle. 3 pi over 2 is down here. That's at the point 0, negative 1, where the cosine is 0 and the sine is negative 1. That means the cosine of 3 pi over 2 is 0 times the cosine of theta plus the sine of 3 pi over 2 is negative 1 times the sine of theta, which leaves us with negative sine of theta, verifying the identity.